Okay, now we are going to talk about n-way set associative cache. So in the last part we have discussed what direct mapped cache. In direct mapped cache, every memory address would maps to exactly only one cache slot. It will be able to match because there is only one set for one block, right? So the problem is that when two popular addresses are mapping to the same slot, popular means these address can be recently used, so conflict misses can happen. This is a problem in direct mapped cache. But in set associative cache, what happened is that the cache can be like different sets are there, where each of these set can have n slots, that is ways. That means if you see here in this picture, you can see that there are different sets and each of the set has two slots, way 0 and way 1. There are two ways in which, so an address which is coming to one set, and if there are two address which is coming to one set, in let's say in set 1 two address is coming, so if in set 1 two address is coming, one address can go in this way and another address can go in this way. In this way the conflict misses can be reduced. Okay, so if you see here how this works, how two-way cache associative works, let's understand that here. That is, in two-way cache, let's say two-way, n is equal to 2. N is equal to 2 means, let us say the total number of blocks in our is 8. We have total 8 blocks. Let us see. So the number of sets would be 8 divided by 2, that is 4 set would be there. That is set 0, set 1, set 2, set 3. Like that 4 set would be there. Because we know number of sets is block divided by n. N would define how many can be there in each of the set. How many ways you can divide. Here you have to understand. Since I got 4 set, that means 2 raised to 2, how many bit would be there? 4 I can write it as in 2's power 2 raised to 2, right? That means 2 bit can only be given to set. So that means in set index would be 2. Byte offset is always 2. And total, if there are 32 bits, the rest 28 bit is for tag. So now you have understood that how many number, if there were 8 set, we write it as 2 raised to 3. So I can write 3 bits for the set. But now it is 4 sets are only there. So that means 2 raised to 2. That means 2 bits would be only given for the set. So that means if I get an address, in that address, first bit 2 bits like in the least significant bits, first 2 bit would represent offset bit, next 2 bits, let's say something like this, would represent the set bits, and the later bits would represent what? The tag. Okay, so a direct mapped 8 word cache would need 3 set bits because log 2 of 8 is 3, but here we are splitting in 2 ways, so we need only 2 set bits, that is log 2 of 4 is 2. That is what you have to understand. So the tag grows from 27 to 28. So there are basically 2 ways now, way 0 and way 1. N is equal to 2 means what? There are 2 ways. Way 0, offset bit is 0 0, and set can go in any of these set, that is 2 bit, and tag bit is now 28 bit. Now we know in each cache there is data part, tag part, and B. Like that there are 2 ways possible. So if an address is matching to set 2, another address is matching to set 2, the first address can go in this way 0 and the other can go in this way 1. So in the data part, this is my data part. The data part would give us the final data. These 2 data we have to take to get the data part. We have this comparator here. This is a comparator. Okay, fine. Now here in the tag, this tag, like first tag, we will check first tag in this way 1, and this tag in the memory address we will check if they are equal, or we will check if this tag and the memories this tag are equal. Okay, and in both of this and we will put the valid bit also, like how we did previously in the direct, we put the valid bit in both of this and. Here also this AND has this valid bit, this AND has this, and we will see which give us hit. So we will do the OR. Any one of them is needed, right? If any one of them gives hit, that is enough. So we will do OR. We don't need to check if both give, right? Only one is needed, so we will do OR gate here. Understood? So this is how this diagram you have to learn for two-way set associative. So the only difference here is that how many n ways means n way you can divide one set. That is what n set associativity means. That is the only difference from the direct mapped cache. Understood? So here the diagram you have to learn. This diagram you have to learn. That is one important thing that you have to learn in this set associative, and this is the diagram for two-way set associative. Fine. Thank you.